weight is not mass. So if I do my job well, you're going to leave here in a few minutes, and you'll have a clear understanding of the difference between weight and mass. People use these terms interchangeably. Some of you will use these terms interchangeably through the end of the unit. I hope you get past that. If I want to measure weight, what I'm really measuring is I'm measuring the force of attraction between me and the Earth. The Earth pulls on me, and the weight is a measure of that gravitational force of attraction. So if I want to know my weight, I put a scale in between me and the Earth. And when I hop on, it says 190 pounds. Well, how much does the Earth weigh? Same. If I turn the scale upside down, and I get on the bottom and make the Earth get on the top, won't it read the same? Doesn't it sound weird to think of the Earth as weighing 190 pounds? We think of weight as something exclusive to us, but weight is a gravitational force of attraction. Now, mass is 70 kilograms, roughly. And wherever I go in the universe, I'll always be 70 kilograms. That's the amount of matter that I've got. And the amount of matter that I have, that 70 kilograms, defines the amount of inertia I have and how resistant I am to changing my motion. So now I want to do the demonstration, and I need a volunteer. This won't hurt. And I want someone else. I'm looking for a particular person to raise their hand. Well, I was hoping Sarah would raise her hand.
She's led off.
Do you want to do this? Good, come on over. You don't have to step on the scale. So just stand right there, Sarah. And this box contains 10,000 copper pennies. I had it sent to me a few years ago, and I've never opened it. So I guess I really don't know if there's 10,000 copper pennies in there, but I do know that 10,000 copper pennies weigh 68 pounds, and this weighs 68 pounds. Now, I'm going to have you lift it in just a minute. So the weight is 68 pounds on the Earth, and the mass on the Earth is 31 kilograms. If I take it to the moon, what changes? The weight, because there's a different gravitational attraction. On the moon, it'll only weigh 11 pounds. The mass hasn't changed, though. It still has the same amount of matter. Okay, so Sarah, I'm going to have you hold this. You got it?
Yeah, I think so.
Okay. Is it hard?
Yeah.
Yeah. Could you throw it?
No,
No?
I don't think so.
Okay, don't. Okay, how hard is it?
Really hard.
Okay. Go ahead and put it down. That's great. Okay, don't go anywhere. Try that. How's that?
Fine.
Fine. Could you throw that?
Yeah,
You might even be able to hit the door.
maybe.
Maybe. Now, there's what's interesting. Okay, you can sit down. On the moon, if I gave her this box, it would feel like this. It would weigh this much. But if I said, throw it, she wouldn't be able to. To throw it, it would feel like she was throwing this. Because on the moon, all the matter that this has is still there. Now, if you're thinking, that's weird, it's because you're thinking, I'm connecting weight and mass. They're very different. So, before you leave today, you should pick this up and then pick this up. Because these are the weights. Weight on the moon, weight on the Earth. But throwing them, exactly the same. Trying to throw these pennies, you would have as much difficulty throwing these here as on the moon. On the moon, if you get on the scale, you'd weigh maybe 20 pounds, 30 pounds. But if you were sitting on a chair and you wanted to jump up quickly, it would be just as hard. You'd feel really light on the scale, but to change your motion rapidly would be just as hard as on the Earth. I hope you get the distinction between those. Elliot.
So, the experience trying to throw the 11-pound box of pennies on the moon would be like, you'd be holding it and it would feel pretty light, and then you just start to move it and it would just
It would be just as
immediately
hard.
get really difficult.
Yep.
All right.
Okay, so we're going to stop there. Thanks.